This whole scanner is running on hardware, no microcontroller, no code. A normal 4017 LED chaser moves in one direction only, Q0 to Q9, and then back from 0 all the way over again. But with a bit of diode steering, we can make the LEDs bounce back and forth, exactly like the classic Knight Rider or Cylon scanner. In this configuration, our 555 timer generates a steady clock signal and a 4017 steps through the outputs. The diodes route these outputs in a symmetric sweep. Let's build it. All you're going to need for this project is LEDs, 5 470 ohm resistors, 2 10k ohm resistors, a 555 timer, a 4017 decade timer, 10 1N4148 diodes or any equivalent diodes, a 10 microfarad capacitor, a 10 nanofarad capacitor, some wires, some jumpers, and a breadboard. Now, let's clear the board. Here's the circuit diagram and breadboard diagram we'll be using for this project. First, we'll start by dropping the 555 timer onto our breadboard. Remember to face the little notch towards the top of the breadboard. I'll put this around the 10 pin on our breadboard. Next, I'll drop in the 4017 decade timer, also with the little notch facing the top of the breadboard. I'll put this around the 25 pin on the breadboard. Next, we'll wire the 555 timer in a stable mode. That means it's free running and makes square waves. So, to do so, pin number 1 will go to ground, pin number 8 will go into the power rail, and pin number 4 will also go into the power rail. Pins number 2 and 6 will be tied together. Pins 2 and 6 being tied together, this is the timing node where we can watch a capacitor charge and discharge. Between pins 7 and power, I'm going to be attaching this 10k ohm resistor. This will be R1. Between 7 and 2 to 6, we'll be attaching another 10k ohm resistor. This is R2. From the 2 to 6 node, we'll be adding our 10 microfarad capacitor. The negative leg goes into ground. Since this is a polarized capacitor, the negative side will need to go into ground. And finally, we'll take a 10 nanofarad capacitor from pins 5 to ground. This helps stabilize the 555 timer's internal reference and gives a cleaner clock. With that, the 555 timer is complete. Pin number 3 from the 555 timer will connect to the clock pin on the 4017. This links the two together. For this one, we'll connect pin number 16 to power. We'll come out of pin number 8 and go into ground. 15 will also go into ground along with pin number 13. Now we can connect our LEDs to our 4017. Because of this configuration, on every rising edge of the clock, the 4017 turns off the current output and turns on the next one, Q0, Q1, Q2, all the way to Q9, and then we'll wrap around. We'll use that to make our back and forth scanner. Next, we'll use our LEDs, with the cathodes facing the top of the board and the anodes facing the bottom of the board. You'll need to leave enough space above and below for the resistor and the diodes. Next, we'll take our 470 ohm resistors and attach them from the cathode to the ground rail of each of the LEDs. Then, we'll need to drop in our diodes. Each LED will get 2 diodes. Important note with these diodes is that the little stripe needs to be facing towards the LEDs. This tells the voltage which direction to flow in. We'll come out of the anode of each LED For our diodes, the left diode will be our first input, and the second diode will be our second input. The little stripe just determines the cathode of the diode, the way that the voltage will flow. Now, the pinouts of the 4017 decade timer are a little confusing in terms of order. That's because they're laid out for the actual efficiency of the chip and not for usability. I will provide the pinouts on the screen as we go through this. Pin number 3 is going to be our first input. Pin number 2 will be the second input. Pin number 4 will be the third input. Pin number 7 will be the fourth input. And pin number 10 will be the fifth input. Now that completes going in this direction. Now we need to go back the other way. Pin number 1 will be our sixth input. Pin number 5 will be our seventh input. Pin number 6 will be our eighth input. Pin number 9 will be our ninth input. And finally, pin number 11 will be our 10th input. Now, as you can see, wiring up the 4017 makes a bit of a mess of the board. Since I've used both sides of the power rail, I'll need to connect the two together. Now, all that's left is to connect it to a 5 volts power source. You can use either a desktop power supply, any number of batteries that combines to that, or you can just use an Arduino Uno because the 5 volt pin is relatively stable, and that's what I'll use since it's beginner friendly. So all you need to do is come into the power rail on one side or the other, and then the ground rail on the other, or this side as well. Plugging in our Uno, we see a consistent from back to forth on our LEDs. As the 4017 counts up, we hit Q0 all the way to Q4, and then from Q5 all the way to Q9. Thanks to the diode mapping, this looks like the LEDs 1, 2, 3, 4, 5, then 5, 4, 3, 2, 1 continuously. The 555 timer just sets our tempo. If you want to change the 10 kilo ohm resistor or the 10 microfarad capacitor, you can change how fast the LEDs move. Optionally, if you want a variable resistor, you can try a 100K potentiometer. Potentiometer on the board, we'll need to remove this resistor. Now, we'll need to wire this in the place of that. We'll come out of the middle pin, the wiper, and we'll have to go into pin number 7 on the 555 timer. We'll actually want to connect the two side pins on the potentiometer to the two 6 jumper pins on the 555 timer. This is a pretty clean replacement of the resistor. Now plugging back in our Arduino Uno, we can see that our lights are a lot faster, or they can be a lot slower. We find that the range of values goes all the way from kind of slow to let's have a party. And there you have it. That's a variable Night Rider scanner demo. This is a great setup for a basic 4017 LED chaser scanner, and it's completely hardware only. No microcontroller, just timing logic. If you want to see a simpler sequential version or other 555 4017 projects, I've also got those on my channel. Thanks for watching, and let me know what you'd like to see next time. Thanks.